Hi, in this video we will be looking at a very elementary mathematical concept. It's not really physics, but it's often essential to understand these very elementary mathematical ideas before we can actually start studying physics. And the first one of these ideas is the measurement of angle in the radian unit. Now when we measure angles, so far we have always measured angles in degrees. In junior classes, when you measure angles, they're always measured in degrees. But now as you approach senior classes or college level physics and mathematics, you start measuring angles in what's called the radian unit. Now what is this radian unit and how does it correspond to degrees? Well, that's the first topic of discussion today, and then a little later we'll also discuss about the small angle assumptions, which are extremely frequently used in physics. So the radian is the angle defined as a ratio of the circular arc and the radius. So if over here we have the arc of a circle, this could be a larger circle here, we are looking at a small arc of this circle which has a radius r. The angle theta over here is now defined as the length of the arc divided by the radius. Now if the radius is large with the same arc length, you have a smaller angle, and if the arc length is larger with the same radius, you get a larger angle. So angle is kind of directly proportional to arc length and inversely proportional to radius, and therefore we arrive at a convenient definition for angle as arc length divided by the radius. Now when we do this, we also need to understand the correspondence between radian and degrees. Now think of an entire circle. The entire circle subtends an angle of 360 degrees at the center. We all are aware of this. Now if the entire circle subtends a 360 degree angle at the center, can we find how many radians that 360 degrees is equal to? Now if we have an entire circle, this arc length will be 2 pi r, and when you divide that by r, you end up with 2 pi. So the entire circle subtends an angle 2 pi at the center. So 2 pi radians is equal to 360 degrees. Therefore 1 degree equals 2 pi by 360 radian, and hence n degrees would be 2 pi n by 360 degrees, the good old unitary method here. Now using this result, if the angle is 30 degrees, you substitute 30 in place of n, you get pi by 6. If in place of n you substitute 45 degrees, you get pi by 4, and so on. 90 degrees finally corresponds to pi by 2. So that's the angle correspondence between radians and degrees. The other small thing that we are going to study here is the small angle assumption. It is very, very frequently used in physics, and I will be using it in my upcoming videos very, very frequently, and so I feel it's essential for you to understand this. What if we have a very small angle? Now if I were to describe it in degrees, it would have to be less than, say, about 5 degrees or so. So we have an angle here which is typically less than 5 degrees, and therefore it would be about pi by 36 radians or something like that. Pi by 36 radians would be about 5 degrees. Now we are going to look at angles which are less than that. Now we have a small angle here, and this is the arc length S. The radius is R, and what I do here is I drop a perpendicular from point P onto this line here. The point here is expressed or named S. This point is Q. The base of this right angle triangle is B, and the perpendicular or the height here is H. For this right angle triangle, the R, the radius, is your hypotenuse. Now if the angle is small and the arc length is also a small arc length, then the height or the perpendicular is approximately equal to S. So H is approximately equal to S, and B, the base of the triangle, is approximately equal to R, this SQ being a very tiny length. In these circumstances, of course we know theta is S by R. In these circumstances, sine theta would be H by R, and H by R would be approximately S by R, which is approximately equal to theta. So sine theta now approximately equals theta. Cos theta will be B by R, this B divided by R. Now since B is approximately equal to R, we get R by R, which is 1. So for very small angles, cos theta equals 1, and tan theta of course would be equal to H by B, H divided by B. H is approximately equal to S, and B is approximately equal to R, and so tan theta is S by R, which is theta. Here therefore, for small angles, we notice that cos theta equals 1, and sine theta and tan theta are approximately equal to each other and also equal to the angle theta. Now this small angle assumption is used extremely frequently in physics and will be very useful for us in the upcoming videos. So thanks very much for watching.